9, 134, identify the type of growth in each table below as linear or non-linear. All right, this isn't going to be bad at all. So if we're identifying as linear or non-linear, let's take a look at our part A. So we could see in the top here that we're just adding 1 each time, which is nice. That really makes it easy on us. So we're just adding 1 every time for our input or our x value. And then in the bottom, let's see, to get from -8 to -1, I would be adding 7. -1 to 0, I'm adding 1. 0 to 1, I would be adding 1. 1 to 8, I would be adding 7. And then 8 to 27, I would be adding 19. All right, so is this linear growth? Is it growing by the same amount each time? No, it's not. So this would be an example of non-linear growth. Now it does not specifically tell you to explain why it's linear or non-linear, but it wouldn't hurt to add that it is not growing by the same amount each time. That way, just writing it, I feel like sometimes helps you to remember the difference between linear and nonlinear. So I am going to erase this before I move on to B, just so it's not such a cluttered mess. And for B, you can also see in the top here that I'm growing by 1 each time. Now let's take a look. So that's for our x value or our input is growing by 1 every time. Now let's look at the bottom. To get from 4 to 6, I would add 2. 6 to 8, I would add 2. 8 to 10, I would add 2. 10 to 12, I would add 2. And 12 to 14, I would add 2. So since we are going up by the same amount, this would be an example of linear growth. And again, we can specify just that it grows by the same amount each time. All right, that's all for B. Again, I'm going to erase this just so it's not so messy for part C. Okay, and part C, we can see that the top, or the x value, or the input, it's still growing by 1 each time. Now the bottom, let's see, we go from 1/4 or 1/4 to 1/2. So to get from 1/4 to 1/2, I'm adding 1/4. Oops, 1/4, not 1/2. So I'm adding 1/4. So 1/4 plus 1/4 is 2/4, which is 1/2. To get from 1/2 to 1, I'm adding 1/2. I don't like that mushy 2. That's a little bit better. All right, to get from 1 to 2, I'm adding 1. 2 to 4, I'm adding 2. And 4 to 8, I'm adding 4. So another way we could word this is just saying that the output, which is y, it doubles each time, right? Because if we do 1/4 times 2, that gives us 1/2. 1/2 times 1/2, or I'm sorry, 1/2 times 2 gives us 1, 1 times 2 gives us 2, 2 times 2 gives us 4, and 4 times 2 gives us 8. Now, in this case, though, we see for our output values, which are what we have for y here, it's still not growing by the same amount. So this is not going to make a straight line if we were to graph it. Same with a, which was nonlinear. So this is an example of nonlinear growth. And that is because, again, it does not grow by the same amount each time. Okay, and that is all for problem 9, 134.